Now, before we move on to the next example, I just want to share something for parents who see their child as being overwhelmed with math, but they're not quite sure what to do about it. Now, in the video that we're watching right now, your child is learning math in a much more natural way that fits with how they think. And if this is working for them so far, I'd like to invite both you and your child to join me for a free online class that they can learn math like this, just like we're doing in the video. To register for this class at no charge, just click the link below in the descriptions, or it's also in the comments, or you can simply go to getmath.net/class. Getmath.net/class. All right, let's continue. And welcome. This is Aurora with Supercharged Math, and we are going to be studying triangles. Okay, now you might be thinking, triangles, what's there to study? I mean, there's 3 corners, there's 3 sides, right? There's a couple of rules I got to remember. Fine. Triangles are so important that engineers take an entire year to study triangles. Okay, all right, let's go ahead and get started. So do AB here. Okay. All right. I'm doing this on purpose because this happens a lot. Okay, I do need to bisect it. Okay, that's correct. Okay, so that was the first step and that was correct. So I just made another point. And what is that point? If I were to connect this, here, I'll do both sides. Bring it up here. Okay. So that's my one. And here's my second one. Okay. And if I were to connect these 2 points, I would get a line that is perpendicular. So here's A and B, here's C and D. Would you agree that AB is perpendicular to CD? Would you agree? Yeah, okay, good. So what I want now is, I want a line that's this long, okay, and that also hits CD. Okay, so what are your ideas? What do we do? There's a couple of different ways to make this triangle. This is just one of them. So I can use my compass here like a ruler. Do you see how I can open it up? So the point and the, here I'll put it this way. So the point and the marker are exactly the width. You see that? Okay. So now I have this set, and without moving it, that's why we don't like to use the other ones, I can swing over on A and make myself a line, and go on B and make myself another line. And what have I just done? This distance is the same as this one, right? If I could make a giant circle and sweep it out, right? And this one is also the same. Oop, I can make another circle and sweep it out. Okay, and then I'm gonna make my triangle in red so it really stands out. My equilateral triangle is now this one. So what did I do that was different than the isosceles one? The isosceles had us going up here, okay, but that was too short, okay, because the side length of the isosceles, okay, is really this long, okay, so it should have gone higher. And now if I measure each side with a ruler, okay, they all measure the same length, and if I measure the angles with my protractor, they're all 60 degrees, which is exactly what they should be. All right, nod your head if you see the difference in what we just did. Yeah, okay, great, perfect. Equilateral triangle. Somebody was asking about another way to do it. Yes, there are multiple ways of making equilateral triangles. This is just one.